ठीक है. हाँ. ओके. बट स्टूडेंट्स तो सर अभी आए ही नहीं. ठीक है. ओके, सो I'll take 2 or 3 minutes, उसके बाद हम स्टार्ट करते हैं. ओके. So today's topic that I'm going to discuss is cyanohydrin. I'm sorry, cyanohydrin is already done. Last class में what you have done, आपने एल्डिहाइड एंड कीटोन्स प्रिपेयर किया होगा, आपने ऑलरेडी कर रखा होगा, तो मैं वहीं से थोड़ा सा अभी आगे चलूंगा. सो बेसिकली अभी जो टॉपिक हम कवर करने वाले हैं एल्डिहाइड एंड कीटोन्स में, वो जो रहेगा वो बेसिकली मैं आपको एक क्वेश्चन दे रहा हूं, तो आपको जल्दी से मुझे उसे करके देना है. इन केस आई गेस आई एम विजिबल टू ऑल ऑफ यू. तो फर्स्ट क्वेश्चन जो आपके लिए है वो इट्स अ बेसिक कन्वर्जन. ओनली इंग्लिश. ऑलराइट. ओके. So it's a basic conversion in which you need to convert acetaldehyde. I guess we all know what is acetaldehyde. Okay. So you need to convert acetaldehyde into lactic acid. And this lactic acid is also known as 2-hydroxypropanoic acid. Okay. So lactic acid or 2-hydroxypropanoic acid. I'm giving you this question because in the previous class you have already done cyanohydrin. So I guess let's start with the conversion. So we all know that acetaldehyde is nothing but ethanol. So I have ethanol, which is CH3C double bond O H, and if I add HCN into it, okay. So we all know that carbonyl group dissociates to form CH3, C positive and O negative with this H. And what I can do here, I can dissociate this H plus Cn negative into, I can dissociate this HCN into H plus and Cn negative. And after that I have to do just one thing. I can combine this negative charge with the positive charge of H plus and the positive charge of carbon to the negative charge of cyanide. Okay. So what we will get here is CH3 C O H, and this H is already present there, and here I can okay, cyanide is here. Okay. And after that what I can do here, so basically this product which is on the screen, this product CH3CHCnOH is cyanohydrin. I guess you already know what is cyanohydrin. And what I can do here now, if I add excess water into it, okay, if I add excess water, excess of H2O, so I guess you already know that when we add excess of water in RCN, then it will actually convert this cyanide group, basically this cyanide group, into COOH, which is the carboxylic acid group. Okay. So the final product is, okay, just wait. Okay, so the final product here is CH3CHCOOH with one OH group. So excess water is added to convert the CN group into, excess water is added to convert the CN group into COOH. Okay, and OH group is already present. So if I name this group, so basically this is the lactic acid, but the IUPAC name is 2-hydroxy. It is the 2-hydroxypropanoic acid. Why propanoic acid? Because Alright, so from Shillong, there's one query, so can you slow down a bit please? Yes, I can. So I'll explain this again. So if you guys are able to hear me, can you raise your hand? Shillong? Can you guys raise your hand if I'm audible to you? Guys, am I audible to you? Okay. So let me explain it again. I'll do it again. Just a second. So the conversion was acid. We need to prepare acid, lactic acid from acetaldehyde. Acetaldehyde is also known as ethanol. Okay, so the formula of ethanol is, we already know that ethanol is CH3CHO. Alright, so it's CH3C double bond O H. Okay, CH3COOH, and we have to prepare lactic acid, which is 2-hydroxypropanoic acid. So 2-hydroxypropanoic acid is CH3COOH H and COOH. Acha, you guys already know what is cyanohydrin? Okay, so if I add HCN, okay, so HCN is added. This HCN can be dissociated into H positive and CN negative. Alright, and the CH3, the carbonyl group of this ethanol will be dissociated to form CH3CO negative H positive. Okay. And now it's just a basic rule, connect the opposite charges. So what I'm doing here, I'll combine this O negative to H plus and C plus to Cn minus, and after this combination the product is CH3C. Now OH is combined with H, okay, and this Cn is now combined with this. Okay. ठीक. So when I hydrolyze this compound H2O and water is in excess, okay. So when I add water in excess, what will it do? It will hydrolyze or convert this cyanide group into oic acid group. Okay? So the product formed is CH3COH H and COOH. So basically this is the compound which is known as lactic acid or 2-hydroxypropanoic acid. Okay? If you have any doubt, please let me know. So the addition of cyanohydrin is done. So basically the formation of cyanohydrin is done, and the next is the reaction with RMGX. Reaction with RMGX. So it is the reaction of pure carbonyls. Okay, I guess you all know what is pure carbonyls. What are the pure carbonyls? Okay, so pure carbonyls are basically the ketone and the aldehyde groups. These groups are known as pure carbonyls, and what we are going to do here, we are going to react these pure carbonyls, that is aldehyde and ketones, with RMGX. Can you tell me what is RMGX? Can somebody? Okay, how did the COOH forms? Okay, let me explain this to you. So basically, there's a doubt from Shillong that how did the COOH form, sir? Okay, so when you add, let me give you a reaction here. It's just a basic conversion that when you add water in excess in a cyanide, okay, just note it down, excess water in cyanide, so it will always form COOOH group, okay, which is the carbonyl group. And let's say in cyanide, if I add limited water, okay, water is added in limited amount. So when you add water in a limited amount, or we can say that partial hydrolysis is taking place. So in that case, amide is formed. Amide is RC double bond O NH2. I guess you already know what is an amide. Okay, and when you add, it is not necessary here, but let's say if I add H2, hydrogen, in the presence of platinum as a catalyst, so in that case what will happen here, it will convert into amine. Amine is RCH2NH2. Okay, so when you add excess water in cyanide, it will always convert itself into oic acid group. And when you add limited water, this limited water addition is also known as partial hydrolysis. So let me mention here, it is also known as partial hydrolysis. You're going to study this reaction in chapter 13, which is the amines. Okay. Okay, so somebody from Itanagar, can you please respond if I'm audible to you, or you're getting what I'm saying here? Okay, can somebody respond from Itanagar? Okay, and the other center is it's Church in Dhampur. So can you please respond? Okay, so there's a message from Itanagar. Okay, so cyanide, when we add excess water into cyanide, it will convert itself into oic acid, and when you add limited water, so basically limited water is partial hydrolysis. So in that situation, amide is formed, and the third reaction is not related to water, but it's good to remember this reaction as well. So when you react hydrogen with not only platinum, you can also use nickel or palladium. You already know that reaction. So when you add hydrogen in the presence of platinum, so in that situation it will form amine. Okay, so can we move further? If okay, so this doubt is clear. So now we are going to discuss here that how this Grignard reagent is going to react with the cyanide, or I'm sorry, not cyanide, with the pure carbonyls. Or pure carbonyls, when I say pure carbonyls, so pure carbonyls combines the ketone and the aldehyde group. So I guess we all know that if I have this carbonyl group, so the carbonyl group, whether it's belong from, whether it's present in the ketone or the aldehyde, it will basically dissociates to form two polar centers, and I can also say two charges. The one is positive charge on the carbon, and the other one is the negative charge, which is O negative. Okay, this okay, let me erase this extra carbon here. Yeah. Okay, and when I talk about RMGX, I guess we already know what is the RMGX. It is known as Grignard reagent. Okay, so there is no response from the third city, which is, I guess, if I'm pronouncing it correct, it's Charchandampur. So if I'm audible there, can you please respond? Okay, so RMGX is basically dissociates to form R negative and MgX positive. So the entire organic chemistry, alright, run on a single concept that you have to combine the positive charge to negative and the negative one to positive. Okay, so let's start with one reaction. Let's say I have ethanol. Acha, you guys already know what is Grignard reagent? Can you respond? Okay. So if I react this, so now I'm moving to the next slide, and in this, let's say I have a compound which is CH3, C double bond O, H, and this is ethanol. Okay, so okay, you already know this. So I'm giving you a simple reaction, a basic conversion, and I just want you to name the product. And what is the product formed here? So convert. So question is, you need to convert acetone to 2-methyl. It's 2-methyl 2-propanol. 2-methyl 2-propanol. Okay, I'm giving you 30 seconds for this. You need to tell me the name. Okay, sorry, not the name. Oh, it's a problem. You won't be able to show me the reaction. Okay, then no problem. We are moving to the next reaction, which is the addition of sodium bisulfite. Okay, so you guys already know what is the sodium bisulfite. It is NaHSO3. Okay, so addition of sodium bisulfite. Okay, so in case of sodium bisulfite, it will again dissociates to form Na plus and HSO3 negative. Okay, and what I have to do, let's say if I consider one compound which is RC double bond O H. Okay, it's just a normal or general formula for an aldehyde. So if I combine this compound with the NaHSO3, so NaHSO3 can be written as Na plus HSO3 negative, and if I consider this carbonyl group, so it will basically form RCO negative positive NH, and now what I have to do, I'll join this negative charge O negative to Na plus and this C positive to HSO4 negative. Okay, and when I combine these two, it will form RCO Na, and after this RCOONA, H is present here, and finally SO3H. Okay, is it clear now, or is there any doubt? Can you please mention? So can we move further? Alright, so after this, what will happen here? As we all know that the sodium salt of this, basically this compound is not stable. So what will happen here? The proton transfer. Acha, you guys already know what is a proton. Proton is H positive. So what will happen here? That this Na plus will exchange its position with this H. So the final product that we are going to get here is COH. This H is already here, and SO3Na. Okay, so this is the addition of sodium bisulfite. No, it's not the case of tautomerism. It's just basically the proton transfer to convert the more stable product. Is it clear, Shillong? Let me repeat it again. It's just basically to form the more stable product. So it is not the part of tautomerism. So the next we are going to discuss here is the addition of alcohol. Okay. So just note it down so that I'll be able to move to the next slide. Can we move to the next slide? Okay, thank you. So I have just, alright, I'll give you some questions at the end. So the next what we are going to do here, we are going to discuss the addition of alcohols. Okay, so addition of ROH. The addition of ROH on obviously on aldehyde and ketone. So I'll start with aldehyde. So let's say I have an aldehyde which is R, C double bond O and H, and if I add R, O, H to it, so this compound will dissociate to form R, C positive, O negative and H here. Okay, and this the ROH group, it will dissociates into RO negative and H plus. And I guess now we all know that what we have to do, we need to combine this positive to negative charge and negative to positive charge. I can guarantee if you learn this thing, it will be easier to learn the organic chemistry, because the 90% reaction of organic chemistry run on this basic concept that you need to combine positive charge to negative and the negative one to positive. Okay, so now if I write the product here, product is R, C, O, R. Okay, so to differentiate these two R's, I'll put a dash over here. So basically this is R dash O negative. Why this dash? To differentiate between the two alkyl groups. Okay, and the next one is it's OH. Okay, and this H is already present there. So this is the basically addition of I would say the addition of alcohol on aldehyde, and the product formed here, the product which is written here is known as hemiacetal. Let me write the spelling here. It is hemiacetal. Okay, hemiacetal. This hemiacetal, okay, so is there any doubt? Hopefully not. So this hemiacetal, I can also say that this is basically the alkoxy alcohol. Why alkoxy? Because this OR is present here. Okay, so this hemiacetal is also known as alkoxy alcohol. Okay, which is not that stable. So you can write down here that the hemiacetal compound is unstable. So what will happen here if I add another molecule? And let me mention one thing here, that this reaction takes place in the presence of dry HCl. Okay, so dry HCl is must. Without this, we cannot establish the equilibrium in this reaction. So dry HCl is must. Okay, and the product formed is hemiacetal, and this hemiacetal is a bit unstable. So if I add another molecule, okay, so can I move to the next slide, because this slide is already full. Okay, so hopefully I have noted down. So I'm moving to the next slide. So the compound that is written here is it was RCOR dash. Okay, and with that one OH group is present there, and it was the H which is already present on the carbonyl group. Okay, so if I add another molecule of ROH, if I add another molecule of, let's say not ROH, it's R-OH. So what will happen here, that this H, okay, I'll change the configuration. If I write this okay, so if I write this ROH in the form of, let's say, HOR dash. I guess you already know that both are the same thing. So what I have to do here now, I'll remove simply the OH and H. So basically I'm removing here 1 mole or 1 molecule of H2O. Okay, and after the removal of 1 molecule of H2O, it is RCOR dash or OR dash, and finally it is H. Okay, and you can one thing you can note here, that the 2 OR dash groups are present on the same carbon. Okay, so when 2 OR group are present on the same carbon, I can use a word here. I guess you are already familiar with the word, which is geminal. Okay, in case of haloalkanes and haloarine, you have studied that when 2 halogens are present on the same carbon, it is known as geminal, and when these 2 groups are present on 2 consecutive carbons, it is known as vicinal. Okay, so this is also known as geminal dialkoxy compound. Okay, why dialkoxy compound? Because ether OR linkage is present here. So this is dialkoxy compound. Okay, and the name of this compound, the previous one, this compound was hemiacetal, and the compound which is formed, okay, so compound is hemiacetal, and the compound which is formed here, the previous compound is hemiacetal and the new compound is acetal. It is ACETAL. Okay, so the acetal compound is formed here, which is slightly more stable as compared to the previous one. So I guess this is clear to all of you. Can we move to the next topic? So basically this is the formation of acetal or hemiacetal from aldehyde. So the next one is ketone, and alright, let's start with the ketone. So I have a compound, let's say if I consider the general formula of the ketone, which is RC double bond O and R, and if I add let's say, okay, not in this form, because if I add into this form it will be difficult to understand. So if I write ketone in this form, R, C, R, double bond O, and if I react this compound with ethylene glycol, I guess you already know what is ethylene glycol. It's CH2, CH2, OH. Okay, so ethane 1,2-diol or 2-hydroxy. I'm sorry, not 2-hydroxy, 1,2-dihydroxy ethane. So if I remove, what I'm going to do here, I'm going to remove one molecule of water. So in one molecule of water, 2 hydrogen and 1 oxygen is present. Okay, so to form water, what I'm going to do here, I'm going to remove this double bond O with this H. Okay, so if I combine these three, it will form here R, C, R, and so the valency in case of oxygen, carbon was forming previously 2 bonds with oxygen, and now both the bonds. Okay, so class of Shillong, are you guys able to, are you getting what I'm saying here? Am I audible? You can raise your hand. Alright, thank you. Okay, so the product formed is O, CH2, O, CH2. Alright, so what I have done here, that I have removed one molecule of water, okay, 2 hydrogen and 1 oxygen to form one molecule of water, and after that I have joined this carbon to this oxygen and the another oxygen of ethylene glycol. Okay, and this compound which is written here, this compound is known as ketal. It's Ketal, ketal. Okay, so this is the reaction of alcohol, or I would say the reaction of alcohol with ketone to form a special type of product which is acetal. I'm sorry, ketal. Okay, so I have obtained acetal in the case of aldehyde and hemiacetal also in the case of aldehyde. So basically, when I react aldehyde with one molecule of water, I'm sorry, not water, it's alcohol. So when I react to one molecule of aldehyde with water, okay, with I'm sorry, with alcohol, so it will form hemiacetal. And if I add another molecule of alcohol into it, so final product which is obtained is, write the answer. Everyone write the answer. It's no answer yet. It's acetal. And when I react ketone with the ethylene glycol, the product formed is ketal. Okay, so hopefully now we can move further from acetal to ketal. And let me add one thing here, that what is the requirement of, it is really important to know that why we add dry HCl in this reaction, the previous reaction. So if I don't add this dry HCl, a small amount of water will be present here. So to absorb this H2O, we add HCl, and HCl absorb this extra amount of water, and this extra amount of water which is removed with the help of HCl help the reaction to proceed in the forward direction. Okay, so let me write it here. We add, it is a very important point. Okay, so HCl is added, to absorb the extra amount of water produced, absorb the water produced, to proceed the reaction into forward equilibrium. I can say in the forward direction. Okay, so just note it down, and after that we are going to move to the next one, which is the ammonia derivative. But hopefully you have no doubt till this topic. If you have any doubt in ketal, acetal, hemiacetal, you can ask. I hope the formation of these compounds are clear. So the next compound that we are going to discuss here is the addition of ammonia derivatives. I guess we all know what is ammonia. It's NH3. Okay. So the next one is ammonia derivatives. Okay. All right. Thank you, Shillong. Hopefully the other cities. Okay. Am I pronouncing it correct? It's Char Chandanpur. Okay. So the next is ammonia derivative. Let's say I have a compound. If I give you the general formula of ammonia derivative, it's NH2Z, where Z, okay, so Z can be another compound. So let's say if I have this carbonyl group, okay, C double bond O, and if I react this group with the ammonia derivative, basically what I have to do here, I have to remove only a single molecule of water, okay, and when I remove this single molecule of water, it's C double bond N Z, okay. So this category which is formed here, which is the C double bond O N Z, is known as hydrazone. So the general name for this compound is hydrazone, okay. We have so many. Can you? All right, sure. It's CC4. All right. So you guys are, I guess, getting what I'm telling you here. So if you have any doubt, you can let me know. So we are discussing here the ammonia derivative, and the ammonia derivative which is reacting with the carbonyl compound is the hydrazone. Okay. So I'll start with the first one. But this is basically the general reaction, what I'm telling you here, that when we react the carbonyl group can be come from both the compound, which is aldehyde or ketone. And when I react it with aldehyde, where are you guys going? Okay, so when I react this ammonia derivative with the carbonyl group, which is in this case, I'm taking it from, let's say, ketone. So the compound form is hydrazone. So the first question that we are going to do on this is a reaction of carbonyl group with the ammonia. So it's C double bond O, and ammonia is NH3, but I can write it like this, okay. All right, so it's NH2H, and if I remove water from here, if I remove water, because to form water I need two atoms of hydrogen and one atom of oxygen. So after removing this, the product formed is C double bond N and simply H, because water is removed, okay. So one molecule of water is removed, and nitrogen is combined with carbon. So I'm writing few reactions here. The reactions are very simple, and the compound formed in this case, this compound is known as imine, I-M-I-N-E, imine, okay. So this is the first reaction when we react the carbonyl group with the ammonia gas. So the second one is if I react the same compound with let's say some amine. Okay, you already know what is amine. Amine is RNH2 group. Okay, so this is basically the primary amine, which is RNH2, and again what I'm doing here, I'm removing water, which is H2O, and the compound formed is C double bond N R. Okay guys, so just note it down and then we'll move to the next one. Okay, so this compound, basically this compound which is formed here is also known as Schiff's base, which we are going to discuss in coming classes, that it is a very important compound for us to differentiate between some aldehyde and ketones. So Schiff base, the common name of this compound is Schiff base, and the next one is H2NR and alright, the third one. The third compound is C double bond O, and now I'm reacting it with NH2OH. So somebody mention the name as quick as possible, the name of the compound NH2OH. What is NH2OH? Itanagar. I'm expecting reply from Itanagar. What is the name of NH2OH? Quick. Alright, no response. It's nothing but the hydroxylamine. This compound is known as hydroxylamine. Okay? So the name of the compound is hydroxylamine, and phenomena is simple. You need to remove H2O only. Okay? And after removing H2O, the compound formed is C double bond NOH, which is known as oxime. It's OXIME, oxime. Okay. So the compound is oxime, C double bond NOH. Shillong is saying that the internet is a bit slow, sir, so late response. Okay, no issues. Hopefully this oxime part is clear to all of you. So it's CNOH, okay, which is known as oxime. So this is the third reaction of ammonia derivative. We have like n number of reactions for this. So the fourth one. Now I'm going to react this carbonyl group with the other compound, which is NH2, NH2. NH2, NH2. In case of NH2, NH2, again, simple task. We need to remove one molecule of water, and in this removal, the compound formed is C double bond N NH2. Okay? So this is a compound which is formed here, and now let me mention the name of these compounds. This NH2, NH2 is known as hydrazine. Okay, so my handwriting is very pure. Let me spell it for you. It's HYDRAZINE. It's hydrazine. Okay, and the compound formed is hydrazone. This is hydrazone. So this is the fourth category, and it's just the basic hydrazine and the hydrazone. And now I'm going to move to the fifth reaction. It's C double bond O plus H2N NH, and this time this NH has a benzene ring. Okay, so your task is simple. What you have to do here, you have to remove water molecule only. So again H2O is removed. Some problem. Okay. So H2O is removed, and after the removal of H2O, the new compound is NH with the benzene ring. Okay, so the benzene ring is there, and the compound initially, this NH2NH is also hydrazine, but this time since the benzene ring is attached with it, the name is phenylhydrazine. Okay, the name is phenylhydrazine. Achha, you guys already know that another name of benzene, apart from benzene, we can also call it phenyl. Okay, so this is phenyl, which is benzene ring, which is C6H5 actually. Okay, and the name of the new compound which is formed is phenyl hydrazone. So the compound which is formed here is phenyl hydrazone. Okay, so I guess is there any doubt? CC4, Itanagar. I'm not getting any response from Itanagar. Students from Itanagar, can you please respond? Hopefully you can. So this was the fifth category, and now the next one is phenyl hydrazone, but this time we are going to, all right, thank you. Okay, just give me a second. So the next reaction is C double bond O, and there's some problem. Yeah. The compound is NH2 and it's basically 2,4-dinitro phenylhydrazine. 2,4-dinitro phenylhydrazine. And again, just simply remove water molecule and write down the product. It's C double bond N. Okay, so the position of bond is a bit wrong. NO2 and NO2. Okay? So the compound, the initially, which was written here, it's 2,4-dinitro phenylhydrazine. It's 2,4-dinitro phenylhydrazine. Okay. Just give me a second. Let me check, change the color of my pen. Yeah. So it's 2,4-dinitro phenylhydrazine. Phenylhydrazine. And the compound which is formed here is 2,4-dinitro phenylhydrazone. Okay, 2,4-dinitro phenylhydrazone. So hopefully no problem till this topic. So the next is, let's start with the next one. Okay. Fifth is done, sixth is done. Now we're moving towards the seventh one, and the seventh one that we are going to discuss is the reaction of ketone with aniline. So I guess you all know what is aniline. It's the aromatic amine, and it's basically the NH2 group on benzene ring. And again, task is simple, just remove water molecule, and the compound form is this. Okay, so let's move to the next one. I guess this one is clear. Okay, the last one is semicarbazide, which is very important compound. So the reaction of again C double bond O plus NH2 NH C double bond O NH2. It has two NH2 groups. First is here, this one, let's say group number 1, and the other one is group number 2. My question is, which group, the first or the second one, react with the carbonyl group? Please answer as quick as possible. Which group will react with the carbonyl group? Or I would say, which group will, participate in the removal of this H2O molecule? Is it the first one or the second one? It is already marked there. Two NH2 groups are present. So which one will react? The first one or the second one? With reason? No response. Shillong? Any answer? Is it the first one or the second one? The second one. Okay. So Itanagar says it's second one. So basically this second one will not participate in the formation of H2 or the formation of compound, because this basically, okay, okay, so this part will involve in the resonance, okay, and due to the formation of or the resonance, the stability of this NH2 group is very high, so it will not participate in the formation of carbazone compound. So the compound formed is C double bond N NH C double bond O NH2. So only the first one will participate here. This time Itanagar is right. So only the first one will participate, and the new compound, which is semi-carbazone. Okay. So this is basically semi-carbazone. Okay. And the compound, the reactant one is semi-carbazide, which is really important compound from exam point of view. So this part is, you can write it down that this part is resonance stabilized, and if the stability is high, so that part will not participate in the bonding, okay, and only the first one is available for carbonyl group to react, and it will form semi-carbazone, okay. So this is the final compound. Now we are moving to the next one, and basically this was the nucleophilic reactions, and now we are going to discuss some reduction reactions, and okay, not reduction. So the next one is reaction. Hopefully you have no doubt. So the next one is reactions involving alpha hydrogen. First I need to tell you that what is the alpha hydrogen. Let's say I have one carbonyl compound which is C double bond OH, and here one CH2 is present, on the other end one CH3 is present. Likewise, I know there is a compound called ketone, or I would say acetone, okay. So this carbon, or basically this group, we already know that this carbon is known as carbonyl carbon, okay. This is known as carbonyl carbon, and the immediate neighbor of carbonyl group is known as alpha carbon. So the immediate neighbor carbon of the carbonyl carbon is known as alpha carbon, and the hydrogen present on that particular carbon is known as alpha hydrogen, okay. So alpha carbon, the hydrogen present on the alpha carbon is alpha hydrogen. Well, in this case, this is the carbonyl part, okay. So if this is the carbonyl part, the immediate neighboring carbon is this one, and the number of alpha hydrogen on this is 2. Likewise, the immediate neighbor of alpha this CH3. This CH3 is beta carbon, and the number of beta carbon on this particular, not beta carbon, the number of beta hydrogen on this particular carbon is 3. Okay, so I guess alpha carbon and hydrogen is clear. So there will be no alpha hydrogen without alpha carbon. So the immediate neighbor of the carbonyl carbon is alpha hydrogen. Okay, so basically now we are going to discuss some reactions in which alpha hydrogen is involved. The first reaction that I am going to tell you is aldol condensation, which is very, very important reaction. It's a name reaction, aldol condensation. So in aldol condensation, two similar molecules of carbonyl compound which has the alpha hydrogens are involved. Let's say if I consider CH3CHO plus CH3CHO. So both the molecules are same and both have 3 alpha hydrogens. The count is not important. Important part is that both the molecules are same and both have equal number of alpha hydrogen. So when I react these hydrogen in the presence of I would say the aqueous NaOH or dilute NaOH, both have the same meaning, aqueous NaOH or dilute NaOH. So it will basically form a compound which is the beta compound. So before writing the product, let's start with the mechanism of this particular compound. So basically what I'm going to tell you here is not exactly the mechanism, it's a kind of a shortcut to learn the product. Okay, so if I have CH3 C double bond O H and here the compound is CH2 H CHO. So carbonyl part from one and alpha hydrogen part from the another carbon, and you have to remove just the the water molecule. Okay, need to remove the water molecule. Let me mark it again. So basically I am removing water molecule from this. Okay, and after the removal of water molecule, I'll join both the carbon. Okay, there's a small mistake. Let me just correct it. I have to remove water molecule only, not the carbon part. Yeah, now it's correct. So the final compound formed here, CH3CH double bond C H CHO. So this is the kind of a shortcut to learn or to find the product in like in not microseconds, but in like 2 to 3 seconds or 5 seconds you can find the product in examination hall. And let me explain it again. What I'm doing here, I'll take the carbonyl part from one carbon or the one molecule and the alpha hydrogen part from the another. Okay? And after this I have removed just one molecule of water here. So removal of one molecule of water minus H2O, and after this I have joined both the carbons with a single bond with the help of double bond. Okay, so with the help of the double bond I have formed this compound. Okay, so let's start with the mechanism. So this is the basic compound. So I have two molecules. The first one is CH3C double bond O H, and the other one is CH3, it can be written as CH2H C double bond O H. Okay, and if I dissociate this carbonyl part, it will form CH3 C O negative, positive, H plus, and now if I consider this bond as the electronegativity of carbon is I would say slightly greater than that of hydrogen. So if I dissociate this bond in this way, okay, so now it will form H positive plus CH2 negative C double bond O H, and I've already told you to form the product what we have to do, we'll combine this positive with the negative of another molecule or ion. So this negative will combine with the positive of this hydrogen, and this positive carbon will combine with this negatively charged carbon, and the product formed here will be CH3 C O H and then CH2 C double bond O and H, and one hydrogen was already present there. Okay, so this is the compound that is formed here. Now if I heat this compound, the one which is present here, if I heat this compound, so what will happen? So if I heat this compound, so after heating, basically dehydration will take place. So for the dehydration, this OH, okay, and hydrogen from this carbon. Why this carbon? Because this carbon is secondary carbon, okay, and the one which is present here is primary, and we all know that the product formed by the secondary carbon is the most stable product, or let me mention the order here: tertiary, then secondary, finally primary. So if I have the secondary carbon, I'll use this carbon to form the double bond instead of the primary one. So now if I heat this compound, the product formed is CH3. Okay, just let me, I'll use the another slide. There is no space over the slide. It's CH3 CHOH. Okay. Okay, so the compound was CH3 CH with one OH and then CH2 C double bond O H, and if I heat this compound here, so basically delta means I'm heating this compound. So what will happen? There are two possibilities. First is the CH2 double bond CH CH2 CHO will be formed, and in other case CH3 CH double bond CH CHO will be there. So if I consider this the compound 1 and this one is the compound 2, so what I am saying here that compound 2 is more stable than that of 1, and why is it so? So let's say if I dissociate this compound, if I dissociate this double bond, so in both the cases CH3 C positive with obviously one H and C negative with H and CHO is there. So this is basically, I'm marking it in red, this basically, this carbon, okay, this carbocation is basically the secondary one. Alright, so now if I dissociate this in another way, so the compound now will be, the compound is, it's CH3 C H negative CH positive CHO. Again, this carbon, you can clearly see that this carbon is attached or bonded with two carbons only. So basically, this carbon is again secondary. So if the double bond is present between second and third carbon, if the double bond is present in between the second and third carbon, so when we dissociate this bond, the compound, or I would say the carbocation formed in both the cases is secondary, which is more stable than the previous one, this one, the first one. Let me dissociate this first one as well. So if I dissociate this double bond, there are two possibilities. First is CH2 positive, CH negative, then CH2 and CHO, or it can form CH2 negative, CH positive, CH2, CHO. Okay, so this one, in this case, the carbocation is primary, but in case of the second one, the carbocation is secondary. So if I compare these two compounds or these two carbocations from the second one, so in second one, both the carbocations, in both the cases, what I'm getting here, I'm getting this secondary carbocation, and the secondary carbocation is comparatively more stable than the primary one. Okay, and that is why the one which is formed in the second case, okay, the one which is formed in the second case is more stable. Okay, because after the dissociation of this double bond, the compound I'm getting will form secondary carbocation in both the cases. And you already know this, that the stability order of carbocation is secondary is the most stable, the tertiary is the most stable, then secondary, finally primary, and last one is methyl carbocation, also known as 0 degree carbocation. Okay, so tertiary is more stable. Acha, you guys already know why tertiary is more stable. Can you mention the reason behind the stability of carbocations? Do it quickly. Mention the reason behind the stability of carbocation. Why tertiary carbocation is the most stable form? And it is very easy. Can somebody mention why tertiary carbocation is the most stable form? Okay, is it electron releasing group? You're right. But can I say that the Itanagar, can you agree with this? Okay, so it's CC4, not Itanagar. So can you agree that the number of hyperconjugating structures are maximum in case of tertiary carbocation? Right? In case of tertiary carbocation, the maximum number of, although your answer is 100% correct, I'm not saying that electron releasing group is not a factor, but there are two factors involved in the stability of carbocation. The first one is electron releasing group, and the second one is the number of hyperconjugating structures. Okay, so in case of tertiary, the number of hyperconjugating structures are 9. Okay, which makes it the most stable carbocation, and in the case of secondary, the number of hyperconjugation structures are 2, and if I consider the primary one, the number of hyperconjugating structures are how many? Only 3. Okay, and in methyl, the number of hyperconjugating structures are 0. Okay, so hyperconjugation, or I would say that the stability all right, the stability of carbocation is a C plus, is directly proportional to number of hyperconjugation structures. Okay, so let's move to the next one. Basically I'm giving a question, I need answer. So now if I react, let's say if I consider this, next page, yeah. So if I consider ketone, which is CH3, C, double bond O, CH3, okay, I have a, okay, yeah, I have 2 molecules of, or I would say 2 moles of CH3, okay, and now I've added aqueous or dilute NaOH. So what is the product formed here? Can you please tell us the number of, yeah, sure, I can. Let me move to the next slide. The previous one, not the next one. So in case of tertiary, the number of hyperconjugation structures are 9, okay? And in case of secondary, the number of hyperconjugation structures are 6. In case of primary, the number of hyperconjugation structures are 3. And in case of methyl, which is also known as 0 degree carbocation, the number of hyperconjugation structures are also 0. Okay? And why is it so? So, let's say, if I consider one tertiary carbocation, C positive, okay, and it has 3 CH3 groups, okay, 3 CH3 groups. So basically, the number of alpha hydrogens present on this particular carbocation are 9, okay, and these are the structure which participates in the formation of hyperconjugating structures. So in case of tertiary, since the number of alpha hydrogens are 9, the number of hyperconjugation structures are also 9. Likewise, if I consider the case of the secondary one, okay, so in case of secondary, let's say 2 methyl groups are present, okay, because we already know that in case of secondary carbocation or secondary carbon, the one which is bonded with 2 carbons only is called the secondary carbon, okay, and I've already told you that the neighbor carbon of the functional group, in this case I would say the carbocation, the immediate neighbor of carbon, the carbocation is alpha and alpha. Since this hydrogen is already present on the I would say the carbocation, so I would not consider this hydrogen as the alpha hydrogen, okay. So the number of alpha hydrogen in case of secondary are 6, so the number of hyperconjugation structures are also 6. So CC Pur, is it clear to you? Can we move to the next one? Can we? Yeah. All right. Now, so the question is CH3 C double bond to CH3. So I'm gonna tell you a basic shortcut to form the product of aldol condensation. You don't have to go through the entire mechanism, because see, in examination hall you don't have that much of time that you're going to write the entire mechanism and then you're going to write the product or find the product in the given options. So if I write this product, this molecule CH3 C CH3 like this with this double bond O, and now what I'll do, I'll write the alpha hydrogen or the alpha carbon in front of this C double bond O, and now finally I will remove, okay, remove the water molecule. What I'll do, I'll remove the water molecule here, okay, so C double bond O is removed, okay, not C double bond O is removed, it's H2O is removed, okay, so one molecule of H2O is removed, and now the compound is CH3 C double bond CH C double bond O CH3, and one CH3 is already present there. So Itanagar and CC4 Shillong, please all of you mention that you got the shortcut. If yes, then I can see the Shillong class. If you got the shortcut, please raise your hand. All right. Thank you very much. And CC Pur, please respond if you got the shortcut. All right. So now we can move to the next one. Okay, so this was the product formed in exam. Let's see, if you're so basically I have given you the shortcut for the exam point of view. Okay, you don't have to use this in your school notebook. Okay, so use this for examinations only. So by using this, you can directly write down the product by removing water molecule only. So this was the aldol condensation, and as I've told you that in case of aldol condensation, alpha hydrogen is must. Okay, so I'm giving a question. I'm writing some molecules here. The first one is let's say it's CH3C double bond O CH3, which is ketone. Let's say this is the molecule number 1, and the other one is HC double bond O H. This is formaldehyde, you already know this. And the third one is, let's say CF3 C double bond O H. Okay, so basically this is the tri-substituted aldehyde with fluorine. So my question is, out of these three, which one? Okay, I'm adding one molecule over here, one more molecule here. The molecule is let's say benzene ring with this double bond, C double bond O and H. Now my question is, out of these four, choose the molecules which would not show the aldol condensation. Which would not show the aldol condensation. CC-Pur, Itanagar, Shillong, please respond. A basic question, out of these four, which are the molecules which would not show the aldol condensation? Okay, it's 2, 3. Okay, CC-Pur says it's 2 only. Itanagar says, okay, now there is a change in answer from CC-Pur, it's 2, 3, 4. Well, the answer is correct. Correct answer is 2, 3, 4. Because in case of compound number 1, alpha carbon has alpha hydrogen. Now Itanagar says only 4. Okay, so now let me explain this. In case of first molecule, which is the ketone, it has alpha carbon, and alpha carbon is also substituted with alpha hydrogen. And in case of aldol condensation, Itanagar, now it says 2, 3, 4. I guess you all got the answer, correct? And but Shillong class, you did not answer. Alright, so if the first molecule will show aldol condensation, then raise your hand. If the first molecule will show the aldol condensation, then raise your hand. Alright. Now if I consider the second molecule is formaldehyde, will it show the aldol condensation? If the answer is no, then raise your hand. If the answer is no, then raise your hand. Alright. The third one, although in case of the third case, it already, what I'm saying here, that in case of third molecule, the third compound, it has the alpha carbon, but the alpha carbon has no alpha hydrogen. And in case of aldol condensation, alpha hydrogen is must. Okay. Now if I consider this fourth case, so alpha carbon is present, but this alpha carbon has no alpha hydrogen. So 4 will not show the aldol condensation. Likewise, second and third, they would not undergo the aldol condensation, but the first one will show the aldol condensation. Why? Because it has the alpha hydrogen. Okay. So hopefully this is clear to all of you. Now let's move to the next one. Okay, I'm giving you some questions for practice, and the compound is, we'll discuss this in the next class. Alright, so the compound is CH3, CH2, CH2, C double bond O, H. Okay? This is the homework question. It's reacting with dilute NaOH. And the other question is CH3, CH2, CH2, C double bond O, CH3. again it has two molecules, two similar molecules, and is reacting with dilute NaOH. It is reacting with dilute NaOH. Okay, so this is these are the two homework questions for all of you. Now the next one. So the next the topic that we are going to discuss is again the aldol condensation, but it is basically there's a difference in this reaction. So this reaction is known as cross aldol. And why we call this this reaction as cross aldol reaction? Because in previous reactions, okay, so if I move to the previous slide, see the molecules, both the molecules are same. Now in this case we can clearly see that when we are reacting dilute NaOH, the molecules that we are taking is acetone, okay, and both the molecules are acetone. So I can say that both the molecules are, when both the molecules are same, okay, so in such cases, the name of the reaction is aldol condensation, or basically I can say it's a normal aldol condensation. But if the molecules are different, so in that situation, the name of the reaction is cross aldol. This reaction is really important. It's a bit complex. I wouldn't say complex, but we need to form 4 products in this compound, so slightly larger than the previous one. Okay. So in case of cross aldol, let's say I have 2 different molecules. First, the name of the molecule is first and the another name is second. So what will happen here, that it will form 4 different products. Okay, what are those 4 different products? The first one is first will react with first, the second one is second will react with second, now the third one is first plus second, and the last one is second plus first. These two, the first two, are known as aldol products because both the molecules are same. But these two, the first plus second and second plus first, these are known as cross aldol products or sometimes cross products. Okay. Now let me mention here that first plus second and second plus first are not same. Okay, Shillong, what is, okay, so basically you're answering here. Okay, so aldol product, if I consider these 2 cross aldol products, these cross aldol products are not same. Shillong, what is 2? Why you guys are replying with this 2? I've got this 2 for like 6 times. Okay, there may be some internet connection issue. Okay, so first plus first, second plus connection, yeah, I've got this. So first plus first, second plus second, then first plus second and second plus first. So basically this cross product in which first plus second and second plus first, these 2 are not the, you know, do not consider these as a mathematics, like in mathematics that we say now that A plus B equals to B plus C, but in that case these the position of first and second is slightly different. Okay, so let's move to the reaction part. And how do we write the product? So let's say I have 2 different molecules. The one is CH3 CHO and the other one is CH3 C double bond O CH3. Okay, so both the molecules are different. So in that case, let's say the ethanol molecule is 1 and this the acetone molecule is 2, the ketone one is 2. Okay, so the first 2 products are the aldol products. So if I write the first product, okay, if I write the first product, it is very simple. It is CH3 CHO will react with CH3 CHO, okay, to form first plus first product. Okay, apply the shortcut as quick as possible and write down the answer. So answer is CH3, CH double bond and then CH again and finally CHO. Okay, so this is basically the aldol product. And why aldol product? Because both the molecules are similar. Now if I write the second one, which is CH3, C double bond O, CH3 plus CH3, C double bond O, CH3. Okay, again I am applying the shortcut, which is CH3, C, CH3 again, double bond, CH, C double bond O, CH3. Okay, so basically these are the two simple aldol products, and just try to write down these two products in your copy without seeing the board. Shillong, Itanagar, Sisipur, if you have any doubt in these two products, please let me know. Itanagar and Sisipur can mention, and Shillong, if you have any doubt, please raise your hand. Alright, so hopefully there is no doubt in Shillong. Sorry. Alright, so let's move to the next one. So the next one is first plus second. So now when I say first plus second, so basically what I'm going to do here, I'm going to dissociate, okay, I'm going to dissociate the carbonyl part. I'm going to dissociate the carbonyl part of the first one. So I'll get C plus O negative and H, and in case of ketone or propanone, I'm going to remove the alpha hydrogen from this molecule. Okay, now again the point is very simple. You already know what we are going to do here. We are going to combine this O negative with this H positive and this negative charge of the carbon with this positive charge of the carbon, and the compound will be CH3, C double bond O, CH2, and then this CH3 O. Okay. CH3CH. Okay, so there might be some, yeah, everything is correct. So CHOH. Now if I heat this compound, so what will happen? The removal of water molecule, and again since this carbon, okay, this carbon is secondary and this one is primary, because see, OH is fixed. I have only one OH, so I have no option other than the second one. But in case of hydrogen, I have two carbon, the one which is the secondary one, the other one is primary. So I've already told you that in case of the secondary, the product is more stable. So the final product that we are going to obtain here is CH3, C double bond, CH double bond, CH and CH3. Okay, so what I've done here, I've removed the alpha hydrogen from the propanone molecule, which is I've already marked the second, and I've dissociated the bond of the first one, the carbonyl part of the first one. Okay, so this was the third product. Now the last one, which is the fourth one, and so let's move to the fourth one. So in case of fourth, now the product is second plus first. So now what I'm going to do here, I'm going to dissociate the carbonyl part of ketone. Previously it was ethanol, ethanol, right? Yeah, ethanol. So now it's CH3, O negative, positive, CH3, and CH3, C double bond O, H will form CH2 negative, CHO with one H positive, that is the alpha hydrogen. Okay, and now the task is simple. I'll combine this positive with the negative of this carbon, and the negative of this with the positive of this hydrogen, and the product, okay, the product will be CH3, C, CH2, CHO, one CH3 is there, and OH. Now if I heat the product, if I heat this product, so now I have again two options. Well, in this case I have three options. This is the primary carbon, primary again, and this one is secondary. Now you guys tell me which one is more stable. It's so obvious, the secondary one is more stable. So the product formed is CH3, C, it's, okay, wait, cannot use the other page. Yep. It will be CH3C, then this double bond CH, CHO, and finally CH3. So this is the final product obtained after the dissociation of carbonyl part of the ketone and the removal of I would say alpha hydrogen from the ethanol part. Okay, so I guess it is clear to all of you that what is the cross aldol. Please respond if you have any doubt in cross aldol, and if you want me to explain it again, I'll explain. Everyone? Alright, so let me repeat it again. So, Shilong, can you tell me which part is not clear? I guess the A and B part is clear because this one is the aldol condensation, right? So, what I'm going to do here, I'm going to explain the third and fourth part to you. Okay? Okay. So, the third one. Okay, let me compare the C and D part, Itanika. Hopefully you will be able to, no, let me do it again. Yeah, C. In case of C, what I am doing here, first plus second, and in case of D is, wait a second, let me, yeah, in case of D, second plus first. Okay, so in case of C, dissociation of, if the dissociation of carbonyl carbon taking place from first, okay, so in case of D, the dissociation of carbonyl carbon will take place from second. Likewise, if I consider this in C, so removal of alpha hydrogen from second. So in case of D, removal of alpha hydrogen from first. Okay, so this is basically I'm doing here, and after that just the basic mechanism by joining plus by minus, plus to minus and minus to plus, I can write down the product like we have already done in case of aldol condensation. So Itanagar, now respond if it's clear, or you want me to explain it again with the help of an example. Okay, so if it's clear to all of you, so I'm giving you a simple question, and I want you to write the product as quick as possible, and once it's done, just mark it here, or Shillong people can raise their hand. So I have two molecules. First is CH3 COO CH3. Okay, and the other one is CH3 CH2 C double bond O H. Okay, now, okay, a small change, a basic change here. This is not CH3, it's ethanol. It will save some time. Okay, so now you have to write all the four products in this case. Okay, start as quick as possible and finish this, and then we'll move to the next one. I'm giving you 3 minutes for this. Once it's done, just Shillong people can raise their hand, and CC Pur and Itanagar, you can mention this on the screen. Two more minutes. Guys, finish this quickly. 1 more minute. And you can actually use the shortcut to write the product. You don't have to write the entire mechanism, so do it. CC Puritanagar, kindly mention if you have done it. Okay. Sipur replied. Itanagar, I'm waiting for your response. Okay. And what about Shillong? Please raise your hand if it's done. Okay. Okay, so let's start with this question. So CH3CHO is given, and so the first product is first plus first. Okay, so first product is first plus first, not first plus second. So in case of first plus first, it's CH3 C double bond O H plus H2C H CHO, and I'll simply remove water molecule from here, and the product formed is CH3 CH double bond CH CHO. Okay, so this is basically the aldol product. And the next one in case okay, this is the molecule. Let me see the molecule. Oh yeah, it's CH3. It's basically propanol. Okay, so in case of propanol, yeah, CH3 CH2 C double bond O H and CH2. Okay, I guess it is clear to all of you that this is the carbonyl carbon, and if this is the carbonyl carbon, so this, the immediate neighbor, is the alpha carbon, and the hydrogens present on this alpha carbons are alpha hydrogens. Okay, so this is H2C with the C double bond O H and CH3. As I've already told you that we have to remove the hydrogen from alpha carbon only. So the product is CH3 CH2 CH double bond C CHO and finally CH3. Okay, so this is the product. Again, this is also the aldol product. So this is aldol product. The previous one was also the aldol product. It's okay, the aldol product. Okay, so now the third one, which is first plus second. So again CH3 C double bond OH. Well, I can also use the same shortcut in this product as well. So it's CH2 C double bond O H and CH3. So oxygen from here and these two hydrogens. Okay, and finally the removal of water, and it will give the final product, which is CH3CH double bond C CHO with this CH3 attached here. So this is basically the cross product. Okay, the cross product, and it was the first plus second. So the last one is D. Well, in case of D, we are going to write second plus first. So it's CH3 C H2 C double bond O H, and now CH3 CHO. Again, water is removed, and after the removal of water, these two carbons are joined together. So the product is CH3CH2 CH double bond CH CHO, and this is also the cross product. Hopefully you all got the same answer. Okay, so this was the cross aldol product, And then the next reaction, and probably the last reaction for the day, is cross aldol. I'm sorry, not cross aldol, mixed aldol. Mixed aldol reaction. So if I consider the aldol one, so in case of aldol, both the molecules are same, similar, identical. Okay, and also they have alpha hydrogens are present. Okay, this was the aldol. In case of cross aldol, molecules are different. Okay, and but yeah, alpha hydrogens were present. Okay, so in case of cross aldol, alpha hydrogens were there. Okay, yes, I can scroll down. Is it visible? Please mention in which you have Shillong, you mentioned something. Sir, can you please scroll down? On which slide? This one? Mixed aldol? Okay. So alpha hydrogens are present. Now if I consider the case of mixed aldol, okay, the case of mixed aldol. So in case of mixed aldol, molecules are different, molecules are not same. Okay, and one with no alpha hydrogen. With no alpha hydrogen. Let's say if I consider a case of ethanol, which is CH3 C double bond O H, and now if I react this with HC double bond O H. So I can clearly see that in case of ethanol, alpha hydrogens are present, but in case of methanol, which is also known as formaldehyde, there is no alpha hydrogen is present. Okay? So in this situation, in this case, only two products are formed. Only two products are formed. I'm sorry, only one product is formed, because since it has no alpha hydrogen, so it has only one option, and this option is dissociation of carbonyl group or carbonyl carbon. Okay, and it has the alpha hydrogen. So in this case, what we'll see that the removal of alpha hydrogen. Okay, so the product formed here will be it's C. Okay, I'll write down the product on the next slide. Hopefully it's clear to this part. So the one molecule which has the alpha hydrogen will remove its or release the alpha hydrogen, and the one which doesn't have the has the alpha hydrogen, it will basically dissociate its carbonyl part. Okay, so let's move to the next slide. Okay, so CH3 C double bond O H plus HC double bond O H. Again, dissociation of alpha part, not alpha part, the carbonyl part, positive, O negative, and H here, and in this case H positive and CH2 negative, C double bond O, H is formed. And see, I've already told you like n number of times what you have to do. Just join this negative with the positive, okay, and this positive with this negative. Okay, so the product formed here If I consider this molecule, the one with no alpha hydrogen as a base, so it is CH2 and now CH2 C double bond O H and one OH group is present here. Okay, so it's CH2 CHO, which is the final product. So in case of formaldehyde, there is no alpha hydrogen, so we have only one option, that we can simply dissociate its carbonyl part, and in case of the ethanol part, ethanol has 3 alpha hydrogen, so we can simply remove one alpha hydrogen from there. So this is the third type of aldol condensation, which is the mixed aldol. Now I have one question for you. So just attempt it and then let me know if you got it correct or not. So I have benzaldehyde. So is there any doubt, Itanagar, CC4 and Shillong in mixed aldol? Kindly mention. If you have any doubt in this mixed aldol part, please mention. Okay, so small question for you. I have benzaldehyde. Just a second, give me a second. Yep. Benzaldehyde. And you need to react it with again ethanol. So benzaldehyde is C double bond O. Basically the aldehyde group on benzene is benzaldehyde. So this is benzaldehyde, and you guys already know what is ethanol. It's CH3 C double bond O H. So now your task is to, okay, so Itanagar, you have no doubt, it is clear to you. Okay, so kindly write down the product as quick as possible. I'll give you 2 minutes for this. Actually 2 minutes are, very, okay, so just do it. CC Pur, please mention if you have any doubt in this. Okay, thank you, Sisibur. Shillong, please raise your hand if you have no doubt. All right, thank you. Okay, so let me write down the product. So basically we can clearly see that the benzaldehyde has no alpha hydrogen. Okay, so if it has no alpha hydrogen, so we will dissociate the carbonyl group or carbonyl part of this molecule. And in case of ethanol, we can clearly see that 3 alpha hydrogens are present. So we will remove the alpha hydrogen from here. So removal of alpha hydrogen takes place from here. So let's use the next slide. So after the dissociation, C, O negative, positive and H, and this is the benzene ring. And in case of ethanol, CH2 negative, C double bond O, H, and this H plus is formed. So I'll join this positive with this negative carbon and this negative oxygen with the positive one. So the final product obtained here is CHOH, CH2, C double bond O, H with the, okay, I need to, yeah, with this benzene ring. Okay, so this is the final product. So this was the last topic for today's class, and now let's have a quick recall that what we have done today. So we have started the class from basically the addition of cyanohydrin, but you have already done that. You guys already know what is the cyanohydrin. So I have given you a conversion, basic conversion that okay, just let me open the first slide. Yeah, so we have started with this conversion acetaldehyde. Okay, thank you very much, Sisipul, from lactic acid to hydroxypropanoic acid, and it was just a basic conversion. And after that, okay, so Grignard reagent, you have already done that. You already know what is Grignard reagent, and then we have discussed this that when we add excess H2O in in case of cyanide, it will convert itself into oic acid, which is basically the, show us the last slide. Yes, Shillong, I can. This one. So this is the final product of aldol cross mixed aldol condensation. And Itanagar, if you have any doubt, please mention. So Shillong, this was the last slide, and is it clear now? So basically, we have done this. We have formed the mixed product on the last slide. So hopefully this is clear. So just a quick revision again. Okay, I can see the movement in Shillong class. I'm still here, guys. So the topics that we have covered today with the reaction of pure carbonyls from reaction of pure carbonyl with the ammonia derivatives, and then we have done ketyl, hemiacetyl, and acetyl. And after that, we have started with the reactions of alpha hydrogen, in which we have studied aldol condensation, for which we need two different, same molecule, and for that purpose we use alpha hydrogen, and okay, not alpha hydrogen, the dilute NaOH, and basically it will give you a single product. Okay, and then we have started with the cross aldol. In cross aldol, we have two categories of product. One with the aldol condensation, the other one with the cross aldol product. So overall 4 products were there in cross aldol, and I've already gave you the shortcut for aldol and cross aldol. And the last one was the mixed aldol, in which 2 different molecules are there, but one molecule has no alpha hydrogen. And if it has no alpha hydrogen, so what we will do, we will dissociate the carbonyl part of that particular molecule, and we will remove the alpha hydrogen from the one which in which the alpha hydrogen is present. Okay, so this is it from my side. Thank you very much, guys. All the best.